Statistical distribution. So now we have a random variable. The first question we want to try to answer is what distribution do this particular random variable follow? Because if we know the statistical distribution, it is very easy to start answering questions using our statistical toolbox. First, a quick note on notation. So we have a random variable, x, which we're gonna now assume gonna follow, which we denote with a tilde symbol, some kind of well-known distribution. And these distributions are given by some parameters that is denoted with the Greek letter theta in the regular case. So when we know which distribution our random variable follow and with which parameters, we actually know everything that can happen. And when we have reached this point, it's very simple to start answering questions like, oh, is it common that people are taller than 190 centimeters? Is it common to have an IQ below 80? Is it common to do A or B? Meaning that it's very simple to start answering questions when we know which distribution a particular random variable is following. There are two main groups of random variables: discrete random variables and continuous random variables. Discrete random variables can only take particular values, like the die example. 1, 2, 3, 4, 5, or 6. Nothing else. So whenever you have a random variable that can only take some very specific values, some discrete values, then you have a discrete random variable. In contrast, if you have a random variable which can take a continuum of different values, then you have a so-called continuous random variable. An easy way to check is this continuous or discrete is to ask, if I increase the measurement precision, will I be able to add additional decimal points to my measure? So for example, die roll, you got 3 dots. Even if you add more decimal points, you will still have a 3. You will not get 3.007 or something like that. It will always be exactly 3. However, if you measure somebody's length and you get them, oh, you're 181 centimeters tall, then you can always increase the number of decimals by increasing the precision you're measuring the length with. So you can say, oh yeah, he is 181 centimeters. But you can also say, oh, he's 181.327 centimeters tall. And you can just continue adding decimal points at the end by increasing the precision. If that's the case, it's a telltale sign that you have a continuous random variable. Throughout this lecture series, we're gonna focus on discrete random variables. And the only reason is because the math becomes simpler when we're using discrete random variables. When we use discrete random variables, we can just add outcomes up. In contrast, when we're using continuous random variables, we will still add them up. The issue though is that we need to use integrals to do it. And for most of us, integrals is a bit too advanced math. So therefore, to avoid the advanced math requirement, we're gonna focus on the discrete random variables when we do our calculations. The neat thing though is that everything we do with discrete random variables will be directly transferable to continuous random variables. So that means all the understandings, all the arguments will still hold when we start working with continuous random variables. So when we have the statistical distribution of a random variable, it's very simple to start applying our statistical toolbox. So in most cases, the first thing we want to know is what statistical distribution do this particular random variable follow? Because when we know which distribution it follows, when we have estimated the parameters, we can actually start telling things about the population, about the truth, about the reality out there in the world.